So we can begin. Today's session will be on Matplotlib, visualization library, and it's similar to how NumPy is the basis of pandas and other libraries beyond. Matplotlib is like the foundation library of more advanced plotting and visualization libraries. So a lot of what we'll do today will involve a lot of steps that you'll see in future libraries like Seaborn will probably take just one line to execute. So as usual, we start off with loading the libraries. The links that I've posted up here, you can check them out, documentation that provides more information about the stuff we're going to talk about. Then we read in the data file that we're going to use. So census merged is the file that we created in last week's class when we merged the population, households, and average household data with the area and density data. Then out of that, we create aggregation of the different statistics for the different sub-counties and just group them as counties. And remember the group by command. But instead, unlike last week when we specified a column that we wanted to aggregate, this time round, we want to aggregate all columns. And so we don't specify a column. We want to get the totals for each sub-county for the various counties. And then we're going to sort by population. We run that. We do head 10 because we just want to focus on the top 10 counties in population. Then now we can start plotting. The first basic plot is just a regular line plot. By default in Matplotlib, if you don't specify what kind of plot you want, it just produces a line plot from your data. And here we want to plot county, the population in each county out of the top 10 counties that we have specified. So this is the command. You call it plt.plot. You specify the X value, the Y value, and then you call plt.show to generate the graph. So we're going to build up the different elements step by step. So the next step, we want to tell what the title of the plot is. That's just plt.title and the name you want to use. Then now we can add the labels to the Y and the X axis, and that is the plt.x label and plt.y label.
So Eric, for the plot, we don't define a plot and give it a name or something. What is PLT here?
PLT is the Matplotlib PyPlot library. So, no.
Oh, okay. So it's not our user-defined, our own defined, like the way we have DF.
No. PLT is just the name that we have given matplotlib.pyplot.
Okay.
So that instead of having to type out this all the time, we just type PLT. So when we call it, we just type PLT.
So you don't assign.
Pardon?
We don't assign a name to it. We just call it as, I mean, like the way we assign DF. That we say the DF now is this data frame, the read Excel. Put it into a variable DF. And onwards, now we say now that variable with that reference. So for the plots, they are real time or something.
It's so the Matplotlib is a library, the same way NumPy and Pandas are.
Yes.
So when we import the library, we just give it a nickname called PLT.
True.
The same way Pandas we refer to as PD, NumPy as NP. You could actually just type out matplot.pyplot.show. Let me do that just and show you.
No, okay, no, not that bit. My point is, imagine I have 2 or 3 plots that I'm 2 or 3 that I'm working on. See the way I would have around 3 data frames.
Yes.
running with.
Yes.
I don't name the plots. Anyway, maybe it might come clear later. So,
well, there's the object-oriented portion of Matplotlib that allows you to do that.
Yes.
But for this lesson, for the purposes of the introduction to data science, you actually don't cover that, because the use of Seaborn and other advanced libraries makes all this much easier to do.
Okay.
It's in the notes that I had sent you. You can check out. You can actually say, okay, I want all plots to be called this name. And then you just refer to that name anytime you want to manipulate that plot in one way or the other.
Okay.
Yeah. Okay. Moses?
Just give me a second, but I was just clarifying that you can call it Matplotlib as any, you can give it any nickname, right? You want.
You can give it any name. Yes.
You don't have to specify
the
PLT.
convention. So we have our basic plot. We have added the title and the labels. So you notice that our X labels are all mashed up. We can use the xticks method of the library and rotate it to whatever degrees we want. And that way, now they look more legible. And you can change this value to whatever brings the best results visually. Say you want to add an additional variable to your plot. It's just as simple as adding this second line, calling the Y value, which in this case is still county, and say we want now to include households. So we change our titles and our Y labels appropriately, run the command, and we get our plot. Now with two variables, you will want to know what each of the line represents. So that way there is the plot.legend command, and then you just pass in a list of the variables, and they have to be in order of how you plotted them. So running that command gives us our legend. A better way to do it is having the label parameter in the plot command. So for the population, you have the appropriate label. For households, the same thing. So that way, when we call plot.legend, now it does not matter what position these two appears in. It's going to give us the correct labels for the correct line. So even if I was to change this line, take it to the top, same thing. It will always label the appropriate data correctly. You can add a grid to your graph using the plot.grid command. Setting it to true gives you a grid. Then you can modify the type of line that you have on your graph. You can either change the color, the type, whether they are markers or not. So in this case, we want to change the population line to a color black and to a dashed line. So this is one of the ways of doing it. You call out the color K and then the type of line. In this case, it's a dashed line. And then for the second line, we just want a color green, but leave the type by the default. That one might be a bit confusing because you'd have to memorize the format and how it should appear. But if you break this into the individual components and call them out separately, it makes it easier. So in this case, we've said we want a color K and we want line style to be dash dash.
Where would we get the list of the defined colors? Because it looks like the colors are codes here.
Yes, they are. If you go to one of the links that I shared up top, yeah, so this link in the documentation has the different characteristics, whether it's for the markers, the type of markers there are, the line styles there are, the colors there are. And you can even use hex codes, which I'm going to show. So for this one, I've added a marker. And so the first line is going to have X as the markers. The second line is going to have O as the markers. And for colors, you can use hex codes. Just put them in quote, hash, and then the code of the color that you want. Then you can change the size of the plot. For that, you use the plot.figure method. So you say you want a figure size, and fig size, you pass in a tuple of the size. The length is the first digit, the width is the second one. So running that changes the plot size for us.
Eric, under the topic plot additional variables, I think a bit on top. So here in this case, you don't need to define the X and the Y axis.
For
the values, it just automatically knows what to put on the X and the Y.
It depends on how you call them here.
Okay. Also, it will always start with X and then the Y.
It starts with X and Y. So you see here, I've changed it. And then now population is now on the Y. I mean, count is now on the Y. I just haven't changed the labels, and population is now on the X. So it depends on how you call it. So you just define depending on what you call first and what you call second.
Okay, I get it.
Any other questions? So that's resizing. Then you can have multiple plots. And for that, you use the subplot method. And the values that you pass in, the first digit is the number of rows. The second digit is the number of columns. The third digit is the plot number. So in this case, we have one row with 2 columns, and we are doing the first plot. So you feed in the details of that first plot using the stuff we've covered previously. And then you call the second plot, same thing. Run the command and you get your 2 plots.
This elaborate further on the when you say one row. What do you mean?
The first digit, it means our output graph is going to have just one row of several plots. If I go to the next example, I've said here that we have 2 rows. So the first digit tells me that it's going to output 2 rows of several plots. And if I run this command, I get my 2 rows of plots. Let me reduce the size a bit. So here I get my 4 plots. 2 plots in the first row, 2 plots in the second row. Then say there's a presentation you have to make and you want to have the plot as part of your presentation. How to save it? Use the plot.savefig method. And then now you just you type in the name of the plot as you want to save it. And you can save it as a JPEG or a PNG. So running that command, plot now appears in my folder. And if I open it, I have it. And that's it for the basic plots. There are very many different plots that you can do with Matplotlib. But for this class, we'll just look at the basic plus 3 other additional plots. So we'll start with the bar plot. This is similar to the basic plot. The only difference is that instead of plot, we'll call bar, plt.bar. And running that command gives us our bar plot. Can also have a combination of the bar plot and the basic line plot. So in this case, we want to get a line plot of the number of households, but a bar plot of the population. And so we specify them appropriately. And so that the line is not hidden behind the bars, it would have to come, oh no, if there's a different color, it doesn't matter. But usually this order at some points might matter depending on what kind of data you're trying to display. So that's something to watch out for. Then say we want to have both of them as bar plots, then we'll just specify both of them plt.bar. But you'll see in our results, households is hidden. That's because when it's plotting, Matplotlib is going to cover the one over the other. This is the case where I was telling you the order matters. However, maybe this is not what we want, the stacked bar. We want them side by side. To do that, so to change it from the stacked type that we have up here, because we want to have them side by side. But by default, Matplotlib shows them one on top of the other. So we have to do some computation where we move one of the bars to the side. And for that, we have to create indices for the X label based on numbers. Since these are categorical values, so we use the np.a range, and then we feed in the length of the counties column. In this case, there's 10 of them. So it's going to provide for us 10 different values. And we are going to use those as indices. So for here, the X ticks, instead of them being the county labels, we'll use these numbers that we have generated from here.
By length, you mean like Meru 4?
No. The number of items in the county column, in the top 10. In this, we have 10 counties in the top 10.
Okay.
Yes, I'm not using the counts for the different statistics. I'm just getting the number of items in the top 10 column, which are the 10 counties. So it's going to generate for me 0 to 10.
Okay.
So by default, the width of the bars is 0.8. Here we want to specify a bar width of 0.3. So that way, when I call the plt.bar method, so for my X value, I don't use county. I say I'm going to use the X indices that I have generated. And that is going, and then I add an extra width of 0.3 so that I can move it from the center and move it to the right by 0.3. And then I also need to make sure that I've changed the width from the default 0.8 to 0.3. For the second plot, I just call the X indices without having to move it. I leave it in place, but make sure to change the width. And then if I run that, I see that now I have the bars side by side instead of stacked one on top of the other like before.
Sorry to take you back. What was arrange doing from NumPy?
It's providing, I want to change the X indices from the different counties to numbers, because this command that I'm doing to change the width of the X labels does not work with categorical values with the strings. It needs numbers because it's making calculations to show how far to move each of the bars, and it cannot do that with the names. That's why I'm using the arrange to generate the numbers for me. And you see, it's to generate indices based on the number of items in my graph. If I had a graph that had maybe 20 or 30 different values or categories that I wanted to graph, then Len would capture that number. So I use arrange to generate the list of numbers that I use in this computation. And this is something that you'll appreciate the beauty of Seaborn, which we'll capture next week. You don't have to do all these things to get results like we have to do here right now. Any other questions?
The previous graph we have figures from 0 to, is it 400? Is it to 4 million?
Yes.
Now here we are having 0 to
0 to 4 million. But you see, the computer, what we are doing is affecting the X axis, not the Y axis. Y axis we are not touching at all.
So why has it changed from the previous one? Or am I not noting something?
You see, in this one, the graphs, the bars are side by side. In the original one, the bars were stacked one above the other. But you see, the Y axis is still the same.
Oh, okay.
Yeah. Okay.
Mine has the millions.
Uh-huh.
I don't know what is different.
Let's go back to the first basic graph. Oh, it's hard to see the decimal points on the numbers. It's 1.5 up to, oh, this one doesn't, it's truncated the numbers. It should be 1.5, 2.5, 3.5, all the way to 4 million.
Same as mine. It doesn't. It has millions as well, and also I don't. It doesn't show me the graph with the black one, the household.
When you run this cell amount right now, 66.
From what is in the file, if you change the plt.xticks, I noted that he has changed the xticks. He has brought it lower than x indices. Let's try that.
Let's go to the indices. So this cell that I'm on right now?
Yes, if you look at the file we are having.
Yes. I made a mistake. The indices, you have to assign the indices before you call it in the computation. So you can move the file, this xticks line, you can move it to below with. Then say you want to show a horizontal bar chart instead of a vertical one. That's just as simple as calling plt.bar h instead of regular bar, it's just bar h. Running that generates the horizontal bar charts for you. So that's it for the bar plots. Then now the scatter plot. And scatter is good when you're looking at two numerical variables. That's just as simple as calling plt.scatter and then the two variables that you want to show. And again, you can change the color to whatever you want and the marker to whatever is specified in the documentation. Run that, you get your file, your graph. Something else that you'll appreciate when you get to Seaborn.
Question, Eric.
Pardon? Yes.
A question.
In
the charter, in the scatter one that you have drawn, is it possible to probably add another variable and maybe a comparison or a correlation?
I'm not so sure about that. I'd have to look into that. But usually, at least I know, when we go to Seaborn, you'll see there's a plot that there's a command that generates several plots based on several variables, which at a glance can help you see. But whether it is more than 2 on 1, I'm not sure. I'd have to look into that.
Okay.
So now for that one of generating the multiple plots, here we just used the subplot command to look at the 5 different, is it 4 or 5 numerical columns and generated our plots from that. So that way. So you see, we've gone through these commands to generate these 4 plots. Once you go to Seaborn, you'll see a command that makes it much easier to do it automatically with much fewer lines of code. Then there's a way, say you want each plot value to have different colors. When we go to Seaborn, you'll see that you can do that by just calling the column that has the different variables, and each variable is automatically assigned a color. But here, when we do this, we get an error. So again, we have to go through a roundabout way to get that done. And we do that by, again, changing that column to numbers using the A range, just as we had done for the X indices in the previous cells. Then now when we call colors and run that command, each of the numbers is a different color for the different counties. Then say we want to use just one color, but then in different gradations. So that way we use the CMap parameter and we want to use blues. So it's going to change the value of the blue based on these colors that we have fed into here. So instead of having 10 different colors, we'll have 10 different shades of one color, in this case, blue. But you notice this value, presumably for Nairobi, is almost invisible. So to correct that, then we add an edge color around our plots. And that way, even the one that is almost invisible is now visible. Then there's also this alpha parameter. Without it, if I was to run the plot, you notice that down here, this circle almost overlays the one next to it. And assuming that they are exactly the same value, then you will not see the one that was underneath. So adding the alpha parameter makes them partially visible. And so that way you can see whatever variable could be underneath the other one. Then you can go one step further and just have each value be a different size. So just like for colors, here in something like Seaborn, you can just call the column that you want with the different values and it automatically generates the sizes for you. But here we'd have to do it manually. So we just specify a list of 10 different sizes, pass that to our parameter, and then when we run it, we get these different sizes. And then we have also added these 2 lines of code here. So we want a color bar that shows us what the different colors mean. Or rather, it's more of a comparison, and this will best be suited for something like, say, a satisfaction survey, where you say that the lightest color is least satisfied, the darkest color is most satisfied. So that way, you call the color bar method, and then you set that, and the label that you're using is intensity. So here we have tons of information in this one graph. Comparison of population versus density. We have the different sizes of the values to show us that differentiation. We have the colors to show us what the different parameters are looking at are. And then we have this intensity graph. Then you notice Nairobi is an outlier. The value is way off. So usually you can change the scale, the scale of your x-axis and y-axis. So if we change to a log scale and run that, Nairobi is still way off, but it's not as way off in this graph as in the previous ones. And again, going to the documentation links that I'd shared up top, will show you the different scales that are available that you can use when you're making your graphs. And that is it for scatter plots. Any questions? So the final graph we'll look at is the histogram. And for that one, it's just as simple as calling it plt.hist and then the value, the variable that you want to plot. So by default, you get this kind of graph. And by default, it brings 10 bins. It bins the values into 10 different categories. So assuming you want to use more or less bins, in this case, let's change it to more. We want to change it to 15 bins. So you just add the parameter bins is equals to 15 into the hist method. And now we have our different. So the bins are the number of groupings you want to have your values in. Say, for example, let's use ages, and you have a survey, you have people who go from 25 to 100, and you want to graph them out in a histogram. But instead of having one continuous graph from 25 to 100, you say you want them to be in age ranges, say from 25 to 35, 36 to 45. So each of those is a bin. So when you're plotting your histogram, it says I have got 10 people in the age range 25 to 35. I've got 5 people in the age range 36 to 45. So those are the bins I'm talking about.
The grouping and the ranges of the bins, are they determined by the population or it's uniform?
It's for the histogram, by default, it just does it 10 bins.
Equal. If it's range, let's say 10 to 50, 10 years
So what,
to 50 years, you have 5. So each is 0 to, 10 to 20, 20 to 30, 30 to 40.
Yes.
Regardless of the number of people in that range.
It divides. So you see what happens that, say there's even 3 individuals, but you have that bin range from 25 to 100. Yes. 2 individuals aged 51 years old, 1 individual is 76. So you'll have from 25 to 35, there'll be 0, 35 to 55, there'll be 2, and then on, and then the last bin will have 1 person.
Okay.
Yeah. So it just generates the bins, and then now it populates the bins based on the data that you have.
Okay.
Yeah. So assuming you want to change the bins here, so you just pass in that value bins is equals to 15, and it calculates based on those 15 bins and spreads out the data evenly through those 15 bins. To make it more visible, you add the edge color equals black, K for black, run that, and you have a graph that is more visible, more legible. There's tons of other plot types that you can play with. So if you go to the links that I shared up there, you can go through the Matplotlib documentation and just go through them. And as an exercise, use the census data to generate plots of different types.
The assignment that you've provided, last week I had an issue. I think I read before. So I was trying to plot a tab plot where you have numerous bar graphs, but you're making a comparison using one bar graph, like a leading bar graph. Then I was unable to do that using Matplotlib.
Matplotlib. It is a tongue twister. Even the name itself.
Yeah. So if anyone has a way of going around it, let me just share how what I was trying to do looks like. I'll share the screenshot of it on the WhatsApp.
Okay.
Just do that now. So I was trying to create something like that. I can try and see if because I was using a data set called cars. It's from R though. So, yeah,
I know that data set.
Yeah. So see if anyone is able to assist me to that in Python. That would be really great.
This is the image Mercy is talking about. Yeah, Matplotlib you might have to go around to do this. But it's a good challenge for every one of us to try out in this coming week leading up to Seaborn on Saturday.
Okay.
Mercy, maybe you can provide share the data set.
Eric, you said you're learning Seaborn on Saturday?
Yes.
Okay.
Sorry, Eric, I was thinking we use the census data.
Okay.
Then we can pick, you can pick different variables that you like to
generate this graph.
Yeah, across, yeah.
Okay.
So the ones that are in one color, like the blue and the second one, that's a continuous variable. So below it shows you the range, like from 0 to 5, then to 15, then to 10 to 15. So the more the colors, I understand, is the more each color represents a category. Then for the continuous one, just one color. So you can see maybe like the number of people in the household is a continuous variable. So you can use that as that. And then the gender can be the second one. It has you're either male, female, or there are 3 or intersex. Yeah.
Okay. Any other questions, comments?
I want to share some command that I use to generate some histogram. Using random numbers. Yeah, and maybe you can have a look at that. It generates yeah, there it is. So it generates a histogram of age versus strength, and it uses random numbers, and you set the standard deviation as well as the average to be used in the plot. So it generates a histogram with a normal curve, normal distribution. and one for a pie chart.
What is the auto PCT thing?
Auto?
Is the auto, I think, auto percentage or something? On the plot.plt.py.
That defines how many decimal places you want to on your values. Like if you want 15.1, you put 1. If you want 15.2 decimal places, then you put 2.
Okay.
Yeah, dot. So one dot, maybe 2 will give you 2 decimal places.
And the F, or it's just
I think that's a value that remains like that. The only thing you change is the dot, whether it's 1 or 2 or 3.
Okay. Thank you.
Any other questions? Anything else? Any contributions? If none, we can end there.